I was working with a group, and we developed a transgenic mouse model that overexpressed adenosine receptors in the heart. Our goal was we thought it would protect the heart from ischemia or low blood flow or hypoxia. And in fact, it did quite a great deal.
The brain growth, the majority of it occurs by age 7. Your long-term brain structure is established by then. So we can really get a sense of sort of what the brain is going to look like down the road at that age. So we were absolutely thrilled that the Children's Heart Foundation funded this long-term study.
We're asking the question whether in babies with heart failure, especially the babies with single ventricle physiology that require only one ventricle to pump systemically, whether that ventricle can be rebuilt, can get a boost, can get rejuvenated with stem cell therapy.
We did this marvelous study where we used a model to mimic this disease called congenitally corrected transposition of the great arteries with ventricular septal defect and pulmonary stenosis, and it worked very well.
For medical device development where there's not a large number of people that need the device, the typical incentives to develop the device don't exist. And so for children with heart defects, that is a persistent problem that can't be changed. If the Fontan circulation is missing this one piece, then the simple solution is just to replace the missing piece. And that's on a simplistic level. The exciting piece of that is that, a Fontan person can be converted back to closer to normal circulation. If such a pump were possible, that person potentially could go on for decades with normal circulation and not be missing the right side pump. My goal in my career is to see single ventricle people live 2 ventricle lives.
I'm just trying to see if I can make the lives of these babies, infants, now moving into teenage years, more fruitful and better outcomes by improving the function of the right ventricle or that single ventricle that these babies have. The Children's Heart Foundation, they are the ones that really brought everything that we have done over the last 14 years to life. In order to answer any question scientifically, you need money, and you need infrastructure, and you need someone to believe in you so that you can carry out this work. The Children's Heart Foundation has been that foundation for us. Because of the foundation, was able to secure NIH grants over the next subsequent years. In fact, now I presently have 4 R01s.
There were a lot of little training grants that I used just to do the fetal MRI study. Those were so important because it takes a lot of time to start a study like this, and those sort of fellowship training grants, which actually you guys fund some of as well, sort of takes a village, I really feel like.
The funding from the Children's Heart Foundation was instrumental because that led directly to, within the next 2 years, getting both an R01 from NIH and then also 2 years later, getting a training grant from the NIH. So it really helped guide us where we really needed some funding to take the next step, and it was critical. That work led me to do a lot of things in pediatric cardiology and in the American Heart Association and for the NIH. That really was jump-started by your foundation.
The Children's Heart Foundation has funded this work and substantially funded it on 2 separate grants that really got this over the finish line.
I think this idea that we had to get funded, it made a difference, and it continues to make a difference. Imagine 25 years of making a difference.
This is the real life proof that research is so important and saves lives.